Hey guys, so this video is going to be all about first creating interaction terms for regression and then running a hierarchical linear regression. All right, so I'm going to go straight to the data. So here we have our data. So we have our categorical variable, which we have dummy coded. We have our dependent variable, and we have our second predictor variable, which we have centered. This is the uncentered one. We don't really need it, so I'm just going to go ahead and delete that. And I'm going to move this one up so that the two predictors are next to each other. So we got our two predictors, and we got our outcome variable. Okay. Well, in regression, in order to check for an interaction between any two variables, whether they're both continuous, whether they're both categorical, or whether one's categorical and one's continuous, you have to create an interaction term, and you do it the same way with every possible variation of predictor types, categorical or continuous. So the way we do it, we go to transform, we go to compute variable, and what we're going to do is we're going to choose a name that reminds us what that interaction is of. So I'm going to put condition by condition D by SPCAV. So that tells me that this is the term of the interaction term between the condition and my second predictor, which is centered. And then to calculate it, all I do is move them over and multiply them. That's it. Click OK. Go back to my data. Boom, there it is. Now running the hierarchical regression, easy peasy. So if you remember, a hierarchical regression is one in which multiple simultaneous regressions are run one after the other. In the first model, you would run the predictors without the interaction term, and the individual betas and I'll show you when we get to the output for each of those that you find in that first model give you the main effects of each of those. Whereas the effect of the interaction that you see in the second model, that would give you the effect of the interaction. But we'll get to that in a second. So to run the regression, we're going to click Analyze, we're going to click Regression, we're going to go over to Linear, and we're going to click that. We're going to put our DV, which is subjective ambivalence, in the dependence box. We're going to put our first two predictors in the independence box. Now we've defined the first model of our hierarchical linear regression with what we've just done. All right. So we're going to predict subjective ambivalence with our condition. That's a categorical IV. So some participants wrote about something that they were ambivalent about. Other participants wrote about something that they were unambivalent about. And then we measured and calculated the index for how wealthy participants or how accessible money was, or people perceived money to be when they were children. Then, so this is the first simultaneous regression. To do the second model, the second simultaneous regression, so this is the first model, the first simultaneous regression. Here we define the second model, or the second simultaneous regression. And here we're just going to move over the interaction. So in the first model, we've got the two predictors independently of one another, and here we've got their interaction. Then we're going to click on Statistics and go to R-squared change. And I often click confidence intervals, and I suggest you do as well, but I'm not going to do it here. Continue, and I'm ready to run. And I click Run. And here pops up our output. You don't really have to pay attention to this one, and you don't really have to pay attention to this one. This one I will mention only briefly because what we're going to look at is right here. All right. So you see model 1 and 2. So this right here, the first line, this is whether or not the two predictors that we entered in that first model together predict significant variance in our DV. So do our condition and our and does perceived childhood income centered, do they together predict significant variance in participant subjective ambivalence? And together they do. The second model, since all we entered was the interaction into that second model, this second model only tells us how much additional variance that interaction accounts for in subjective ambivalence and whether that's significant or not, and it's not. All right, so if we scroll down, okay, the most important model is this coefficients table. So we're going, if we were looking at main effects of condition, we would look in model 1, find condition, and here's the unstandardized beta, here's the standard error, here's the standardized beta, here's the t-test, testing whether or not this slope is significantly different from 0, and here's the significance of that t-test. And yes, indeed, condition is a significant predictor of subjective ambivalence. So one was people in the condition 1 were made to write about something they were ambivalent about. People who in condition 0 were made to write about something that they were unambivalent about. And lo and behold, though there's a positive relationship. So as people move, so people in the ambivalent condition felt more subjectively ambivalent than did people in the unambivalent condition. No surprise there. We also find a significant positive effect for perceived childhood income. So as participants felt, and we know this is positive because there's no negative numbers here, so it can be negative, so you see down here, but there's no negatives here. So what we know is that as participants thought their childhood income increased, they felt more subjectively ambivalent. Now to look for the interaction, we look at model 2, we go to the interaction term and we look across. Here's the unstandardized beta, the standard error, the standardized beta, the t-test saying whether or not, on the t-test you can kind of ignore the sign, but the t-test tells us whether or not this beta, or this one rather actually, was significantly different from 0, and it was not. Okay, so this tells us that although we have a main effect of both of these, we do not have an interaction. Now let's imagine that we did. All right, let's imagine that we did have an interaction. Well, we would then look to the simple slopes, or the simple main effects, and we find those also in the second model. So in the second model, this is the simple main effect of condition when this one is 0. So this is the effective condition when perceived childhood income is 0. Well, you remember, since I centered it, 0 actually means the mean. So this is the effect of condition at the average value of perceived income. All right. This, on the other hand, this right here, this is the simple main effect of perceived childhood income when condition is at 0. Well, remember that for this, when condition is 0, that's the unambivalent condition. So when participants ran or wrote about something that they were unambivalent about, then the more money, the wealthier they thought they were as a child, the more ambivalent they felt. All right. Again, we know that because it's positive. So to find out what the effect of perceived childhood income would be for those who wrote about something they were ambivalent about, we would have to reverse code this, or not reverse code it, but we would have to, well, yeah, we'd reverse code it, but what that essentially means here is we would go in and reassign the values. So I'll show you how you do that. You go to transform, compute into different variables, and you'd move condition over, give it a new name. I'm going to put R there just so I know that it's flipped, and I'm going to mention to myself what 0 is. So in this one, 0 would equal the ambivalence condition. And then I click change. Then I go in here and assign what the values are. So you see old value here. So if the old value was a 1, you see a new value here, then it should have a new value of 0. And I'm going to click add. If it had an old value of 0, and it had then we want it to have a new value of 1. So this makes all the 1s into 0s and all the 0s into 1, so it flips it. So in the original condition, 1 meant they got the ambivalence condition, and 0 meant that they got the unambivalence condition. So we flipped it. So now 1 means they got the unambivalent condition, and 0 means they got the ambivalent condition. And so we click and continue. and OK. But now we have to recalculate our interaction term. So we go to transform, compute variable. All I'm going to do, I'm going to put an R on there. I'm going to put an R on there since it's basically the same. See, right click and click display variable names. It helps me. But you can see there that the only difference between these two is that there's an R. So I just typed in an R there. And then I click OK, go to my data, and there's the new interaction term. So then I rerun my regression. I change out cond dum for the reverse coded condition. So cond condition dum dummy coded are reversed. All right, so that cond condition dum dummy coded. All right. It just occurred to me what that spells out. I'm a moron sometimes. Sorry, guys. Anyway, so we're going to move the reverse coded one over. Click next. And we're going to replace it with the new interaction term. All right. Click statistics just to make sure these things are still clicked, like our squared change. Click continue and OK. So here's our new regression. You'll notice these values didn't change, and neither did any of these. But this number did change. Because now, because remember that with the simple slopes, this is the effect of perceived childhood income when this one is 0. And as we can see from the label here, 0 is in the ambivalence condition. So when they're ambivalent, all right, so when they're ambivalent, there's no relationship between their perceived childhood income and how subjectively ambivalent they feel. That's basically 0, and that interaction and that t-test is not significant. All right, the interaction is still the same as it was. These main effects are still the same as it was, but the simple main effect of perceived childhood income has changed from here. All right, so those numbers are different than sorry. And these numbers. Okay. So those are simple slopes, and you could do the exact same thing looking at the effect of the dummy-coded condition variable at high 1 standard deviation above and low 1 standard deviation below levels of perceived childhood income. All right, and that, my friends, is how you run a hierarchical linear regression, and that's where you look for the main effects, and that's where you look for the interaction and the simple slopes. All right, guys, that is it for this video. As always, if you have any questions, let me know. Otherwise, take it easy.